All right, in this video, what we're going to do is find the critical points of some functions, and those critical points, by definition, they're in the domain of the function. And so, all right, let's go through the steps of how we find the critical points. So the steps are that we first find the derivative. So obviously, that depending on the function, that could be easy or it could be difficult. So here I'm going to use the power rule, and therefore I should change square root of x into x to the 1/2. And then when I take the derivative, I use the power rule, so I have 4. The derivative of x to the 1/2 is 1/2 x to the minus 1/2, and the derivative of x squared is 2x. So 4 times 1/2 is 2. And then I could, if I feel like it, which I do, express x to the minus 1/2 as 1 over x to the 1/2, which in turn is 1 over the square root of x. Now, that's just step one. The next step is to ask ourselves, are there any numbers that are not in the domain of f prime? In other words, f prime of that number is undefined. But at the same time, f prime of the number is undefined. That makes a critical number if that same number is not in the domain of f. That's hard to take in because if I just say it, but find numbers, say, or such that, let's say find numbers c such that f prime of c is undefined. In other words, it's not in the domain of f prime, but c is in the domain of f. It makes it seem more complicated than it is, but because look, when you have f prime, you're not allowed, f prime as a fraction. And in that fraction, 2 over square root of x, we see there's x. And we also know in fractions we're not allowed to divide by 0. So the answer is, we see that f prime of c of f prime of 0 is equal to 2 over square root of 0 minus 2 times 0, which is undefined. I mean, in a way, I don't even feel like writing equals. In fact, I think I will somehow withdraw from equals and write just the word gives, because it's just undefined. And because it's undefined, that means that, well, it's not just all that, but it means that x equals 0 is going to be a critical number. Critical number is if f prime is of that number, f prime of 0 is undefined. But note, f of 0 is equal to 4 square root of 0 minus 0 squared equals 0. So 0 is in the domain of f. It seems like a whole lot. Just look, you can't divide by 0, right? You're not allowed to divide by 0. So therefore, you would think that f prime of 0, f prime of 0 is undefined, so you think x equals 0 is a critical number. But you need to check and ask yourself, but is 0 in the domain of the original function? And it is. So that's what makes it a critical number. So x equals 0 is a critical number, and that's just one critical number. And by the way, if I had not written the derivative in the form that I did write it, where I write 2 over square root of x, if I hadn't done that, I might have missed the idea that 0 is not in the domain of f prime. Because if I just write 0 to the negative 1/2, I mean, I know that that's undefined, but it could be something that's missed. All right, so we have that one. And then the next one is Step 3, and by the way, step 1 has to be find the derivative, but the other steps, it's questionable which order, it's just up to each person which order they want to use. Step 3 is we're going to solve f prime of x equals 0. So by definition, a critical number is where f prime is undefined and where f prime is equal to 0. It's those values of x, where f prime is undefined or f prime is 0, and those values need to be in the domain of the original function. Now f prime of x is equal to, again, 2 over square root of x minus 2x. And so if I set that equal to 0, there's different ways to go about this. But, man, I'm using a lot of space here. But what I'm going to do is I'm going to find a common denominator. I could see someone not really wanting to do it that way. But, there's maybe in another next problem I might do it a different way. But anyway, I'm going to just get a common denominator, which is the square root of x. So then I'm going to get 2 minus 2x radical x over radical x is equal to 0. And then I guess I'll add a page here. So this is a fraction. And again, we see when x is equal to 0, the whole thing's undefined. So this right here is f prime of x. But what I'm trying to find is when is the derivative equal to 0? And if it's a fraction, the only way a fraction can equal 0 is if the numerator is 0. So then I'll have 2 equals 2x radical x. Divide both sides by 2. And then it's probably better if I write x to the 3/2. Well, let me make sure that that's clear. This is x times x to the 1/2. X to the 1 times x to the 1/2. So that makes x to the 3/2. And look, there's only one answer is 1. It wouldn't be -1 either, all right? So let's look what I'm doing. I'm going to take x to the 3/2 equals 1, and I'm going to multiply both those sides, or not multiply, raise both those sides to the 2/3 power. And that gives x equals 1. Maybe you wouldn't even have to do that step. So in summary, and 1 is in the domain of the original function. So the critical numbers are x equals 0 and x equals 1. I think I could have done this a lot faster, especially in step 3, when I get a common denominator, write f prime of x. You can, from there, just see that x equals 0 gives something where f prime is undefined. That gives a critical number. And then it's pretty quick to find when the numerator is equal to 0. Okay, so I should zoom out, I guess, and get that whole thing in there. I feel like I made the problem look like it's longer than it really is. But anyway, I was explaining a lot, talking a lot. These are from, this is an Openstax problem. It's from Openstax Calculus Volume 1. And it's in the section on absolute maximum minima, problem 109. All right, that's all.